talk about in the next few minutes is my experience of AI and ML in a manufacturing environment. So firstly, what are we trying to do? I'm assuming we're all here because we want to improve quality, improve operations, drive down unit costs, build better next generation products, be more responsive to customers, and many, many more. But what does that mean in terms of actual physical things that need to happen? So I think what we're doing is trying to push knowledge through the enterprise. And this is not only putting knowledge down to the level where it needs, but also giving it meaning, to a certain extent context, but also being able to build on years and years of experience, condensing that down into intelligence in our systems. We need to automate the process. And this is, again, not just the process of delivery, but also one of understanding what's going on. So not only do you get delivered a piece of information, but that piece of information has context too. An example that happened recently of context is that my elderly mother had to have a blood test, regular, normal thing that our doctor does for them. And later in the evening, she has a call at midnight to say that they're sending an ambulance round and she's got to go into hospital because the blood test results are abnormal. Eventually, to get a very long story very, very short, it turns out that her blood is abnormal, but it's normal for her. So the context there was there's nothing wrong. But most importantly, I think, is we have to focus on the outcomes. We're all told to use the scientific method, which is hypothesis, null hypothesis, rejection, acceptance. But that doesn't really mean anything to a business. What we have to do is focus on a business outcome and then work backwards through the process. Can I ship more deliveries? Why is something taking time? And there we can also get a better understanding and also what that will mean in terms of monetary value to our customers. So very, very simple. In a very prescriptive, very simplistic way, my formula for success is as follows. So artificial intelligence needs machine learning, human in the loop, and training data. So to put simply, this is what we're going to talk about. Before we carry on, though, I think I need to discuss some definitions. AI is not a new term. It started in the 1950s with the Ferranti Mark I. Then it was coined in 1956 by John McCarthy. And since then, it's gone through many different guises, many different definitions. Sometimes AI and machine learning are converging, sometimes they're diverging. But I think that the definition that I've got 70 years of research down into two slides, two comments, that it's based on mimicking human behavior. But it's not merely human reasoning, it's also taking things that we observe in nature. For example, swarm, how small devices like insects guard themselves, protect themselves, or work together to achieve bigger things. The same things happening in biology with bacteria protecting themselves till there's enough of them to infect the host. Machine learning, on the other hand, is using statistically based methods which allow computers to learn without effectively imposing rules on them. Again, not a new concept, 1952. Date was the first use by Arthur Samuel, but again, it's blurred. ML is usually concerned with prediction, clustering, finding out outliers. as a data scientist, we spend most of our time doing that type of thing. But also, each technique has its limitations, which again need to be taken into concern. It's not a simple thing of you apply a machine learning technique and you get an answer. As I said before, there's been a lot of discussion about where it fits and how does machine learning and AI fit together. Top right, we've got a nice diagram. If you all go and Google MIT, is it AI? You get a nice decision tree of what MIT thinks it is. You have some people that think deep learning is part of machine learning, which is part of AI. Other people see AI and machine learning as completely separate entities, with deep learning moving towards artificial intelligence. My view is much more pragmatic in that it's a progression. You start with simple reports, you go to business intelligence, you use advanced analytics, you take machine learning, and eventually you end up with AI. This is more and more sophisticated over time. And often the jump from advanced analytics to machine learning to AI is funded by easier access to algorithms, cheaper computing, which again means that it's pushed down to more and more organizations. And it's not merely a case of building an AI model and then delivering it. How to deliver that to an organization is really critical. And also the ability of the organization to understand what's being said is also critical. And again, that's a separate track, which we'll perhaps discuss later, that comes into it. So the next thing is the role of the human in the loop. And a while ago, I was at a data conference where somebody who was a director of a very large consulting company stood up and said, data scientists, they're all alchemists. And by that, he meant that they were magicians and illusionists. At first, I was slightly hurt by this, but then after thinking about it, he was right to a certain extent in that we are all trying to impress some noble, some lord, a king, director of marketing, to convince them that we can convert something which is seemingly useless into something which is of great value to them. And I think the successful ones make the transition from alchemist to scientist. And I'm unhappy with the word scientist because I think we are more explorers, because we don't necessarily follow a scientific route. We don't always follow the scientific principles, but we explore forward. But data explorer is perhaps an even sillier word than data scientist. And these people who are your data scientists, your data engineers, your analysts, your research engineers, this is also where AI can help, because they are prime candidates to be replaced by AI. And that's not merely in terms of the simple drudgery stuff of preparing data, cleaning data, making sure the data is usable, but also in feature generation and in model selection. We're already seeing this in a number of products where you have auto prepare, auto model. And I see this as a positive thing because it removes the bias from model selection. Too often I've seen that a data scientist will always choose neural networks because he understands them, he likes them, and he thinks they're cool, when often other simpler models will suffice. And it also makes sure that you don't forget things like, forgetting that native Bayes assumes independent variables. It makes you follow at least some rigor. Very quick aside before I carry on and look at the real key thing, which is data. I would suggest that it's really important to have a data strategy in place, particularly in an engineering environment where the engineers are used to working to policy, document, process, tolerances, standards. I'm not suggesting that we have option one, which is wishful thinking and marketing. Equally, I wouldn't suggest that you have a Wardley map, which is something we used to use internally to convey where we're going very, very quickly, because they need to change very, very fast. And engineers will always say it can't be strategy if it changes every 3 months. What I would suggest you have is something that is tangible. This is the one that we used at Konecranes when I was there, and we used it because it's visible, and some of these things existed in other parts of the organization. Master data management, for example, sat with a product group. Compliance sat with various different groups, and then we were adding things like data architecture, advanced data and analytics. And this enables you to have some framework against which you can explain what you're doing, why you're doing it, how you're going to do it, and beyond just having a set of rules to which you apply compliance or standards to. So, as I'm sure you are all aware, it's all about the data. Data is a common denominator for all of these processes. We start with data. And the key word here is training. All machine learning algorithms need data to train themselves against. They need data to validate as well, but also to test, but the majority of it is training. And the word training helps others understand what you're trying to do. It's less fluffy. It's more fluffy. It's not as challenging. You can explain why I need access to your payroll system because I need the data to train against. It gives some reassurance to the organization where it's not always clear to them what you're trying to do. And of course, it's abundantly clear to you, and you can't see why anybody should want to stop you. Second thing is that it's all the laws of statistics still apply. No matter how big your data is, laws of statistics still apply, and all the good stuff about doing tests, understanding how the data is distributed still apply. And this is also the first step in your analysis. As soon as you get the data, to see what shape it is, what you've got, what you haven't got. Another thing is, don't get hung up about quality. Assume your data is wrong. Your data will be messy. It will be incomplete. There will be things missing. You will have to make assumptions. And this is all part of the data scientist and data engineer's role, is to deal with messy data. And we spend most of our time, unfortunately, cleaning up messy data. Simple example, we were doing some address cleaning once, and we found 11 different ways of spelling St. John's, which is a place in Newfoundland. Very, very simple word, 2 words, St. John's. We found 11 different derivations of it. The next thing that's important is relevance. And this is interesting because relevance is you will not know today what is relevant tomorrow or the week after. The tweet from the disgruntled user last week, is that still relevant this week? Probably only if he then tweets several times more. But it's also governed by the business. Yes, it's possible to store everything forever. Yes, you can do it. Do you have to? In some cases, like nuclear installations, you have to. The nature of this is repetitive. Not only is the data science development process repetitive in that you try things, it doesn't work, you try something else, it gets better, but also it comes as a shock to the business is that once you've put an algorithm into use and into place, you're constantly monitoring that algorithm to see whether or not it's performing. You're then producing second, third, fourth generation algorithms and going back to the business on a regular basis to say, is this working? Is this better than this? Is really confusing, because often, we developed the P&L report 10 years ago and it's still the same today. Why are you bothering me? And for the data science community, it's also interesting because of this constant relooking, reevaluation, you have to be quite robust in defending your own judgment. Why did I choose that particular model? Why did I choose such data features? How did I come to that conclusion? And it's quite interesting that particularly some of the more older and experienced people sometimes get quite upset by the new people arriving and constantly asking why. Equally, the new people often feel that they never free themselves from an algorithm or a project. They keep repeating it. It's like doing the same assignment over and over again. Again, part and parcel of being in data. Start small is often easier than going big. That doesn't mean that big data is difficult or expensive. These days it's relatively easy, but it's about keeping things manageable. If you're forecasting raw material shortages, customer demand, and weather patterns, whilst trying to regulate production throughput, you'll have a huge set of extraordinarily complex and interdependent variables. Often it's very, very simple just to find something simple, small question, small amount of data, easily understood that you can process. One of the first projects I can remember doing was to do with a particular type of sales case for a sales director in Europe, Middle East and Africa. So we had very, very small amount of data, tens of thousands of rows. And he simple wanted to know is his sales management working? Very small, very simple, but fortunately we found out. So finally, at this point, I was going to start looking at projects that I'd done. And then I realized that projects that were relevant for one industry may not be relevant for another industry. So I then thought about do I do core 20 best data science projects, 24 essential projects? But looking at the title of this, it's all about the data. So I then started thinking about the data. And I started with, where does my data come from? Well, I have transactional data, which usually sits in an ERP system and usually has some financial value attached to it. You have your operational systems. These are your CRM, your HR, your product lifecycle management systems. You're then getting experience data, which is your surveys, your social media, feedback. And then I realized that I was thinking about this wrongly. I was worrying about where the data comes from or what the data is. It's just data. All you need is access to that data. So I then thought about internal and external, and this was, again, slightly moving on from the classic approach is to say, is it primary or is it secondary? Primary data is data I've created. Secondary data is something which somebody else creates and I'm consuming. And usually and I started this because usually internal data, you have an internal battle to get access to it. External data, usually you have to involve IT, security, risk, to make sure that that data is safe, that it's licensed, that it's available, that it can be brought into the organization. And this gets even more confused when you end up with IoT data. because IoT data could be data which sits in your machine, on your factory floor, that then goes somewhere else, that then gets processed, and then you have access to that data by an API or by file transfer or by some other means. And it gets complicated. And what I'm trying to really get onto is it's just about data. And it's about processing data, and it's about access to data. People used to get upset with me when I used to say that, anybody that gets between me and the data is the enemy. And that is quite hard, it's quite confrontational, but it puts it succinctly. You need the data to succeed. The other piece of data which I thought about, and which we've spent a lot of time doing, is the process data. How something moves through a factory, your sales cycle. And we've done a lot of work with this. In the past, it was done through a very expensive report generator, which comes off from our ERP systems. But it didn't actually help, because it just told you what you already know. Is some things took longer, some things took shorter. So what we did, by taking one of our products, which is our a configured to order, we then started applying clustering techniques to find out where we had similar and where we had divergent configurations. And you learn that certain things which are held true by the business, the data doesn't support. As an example, they thought that frame size dictated whether something was easy or simple to produce, on the fact that they are used to producing frame sizes A and B, and C, D, and E were the problem because they are larger. It turns out that when you cluster everything by configuration, you find that there are other factors involved in whether or not something goes through the factory as expected, what we used to call a happy flow. And then this helped, by analyzing what the bottlenecks were and why things had to be reworked, we then realized that often it was the humans in the loop earlier in the process that would change something from type A to type B that would then cause problems. We also did a lot of work when it came to certain factories producing, again, be very careful doing any confidential things, but producing hoists that day. They used to have a flight board of what we expect to go out that day. We were using data to then predict which of those builds or which particular station would cause a problem based on labor availability or material availability or pipeline availability. And again, rather than somebody manually building the board by searching through various systems, we then found a way of just displaying that data to them quickly and more easily. And then they could, rather than spend the time assembling the data, they could spend time dealing with the outcomes. I didn't even get as far as mentioning metadata, which is the data behind the data, which in manufacturing is really key, because you need to be able to identify things. I've spent many a dull afternoon in meetings discussing what is a serial number, and in the end we decided just to dump all the data out to use machine learning algorithms to extract all the data from all the documents, and then come up with these are the probable serial numbers, because the outcome was we wanted to be able to find a parts list for a particular machine, but we're not quite sure what it was called. So we developed that very, very quickly as an example. And again, that's something I really, again, start small, start little. Don't necessarily go for the big things. Start small, pilot, and then grow into production. So finally, I'm sorry about this slide. I really was trying to ascertain a way of saying that everything's interrelated. Using data to build your business is a team sport. It's not about individuals. It's about the technology people being able to deliver things, having data people who can analyze what's going on, dealing with business people who can then implement and then start the process off again by asking more pertinent and relevant questions. And again, underlying everything here is data and access to it. Right. Thank you. That's the end of my presentation. I've tried to be as succinct as possible, and I thank you very much.
Thank you so much, Alun. Can you hear me?
Yes, I can hear you, Swap.
Yeah, so I think thank you so much on behalf of the people who have come in for the conference, and from me and from Vijay as well. Thank you so much for joining in. I will connect back with you the moment we are done with the conference anyways. Okay?
Yep, no problem. Thank you very much. Have a good day.
Thank you, Alun. Yeah.